homework 4, graphing quadratic equations and inequalities from standard form. We'll have a different form later, but this day was all about standard form, which is this ax squared plus bx plus c. All right, so we are taking kind of the first couple topics that we did and combining them into one type of problem with this first page here. So very first thing that you guys do is figure out whether the function has a minimum or a maximum, and that's all based on this leading term right here. So that leading term is something that's positive, and when it's something that's positive, you know the graph is going to open upward like this. So the vertex would be the very lowest point on the graph if you know that it opens upward. So if that's the very lowest point, you would say that something has a minimum. So whenever this is a positive number, you would say that you have a minimum, which is kind of counterintuitive from what you think the rule might be. But whenever this is a positive number, you have a minimum, which means the opposite is true as well. All right, so the axis of symmetry, that is the next thing that you guys are going to find. So you have this formula, looks like this, x equals negative b over 2a, that you guys are going to be using whenever you're asked for the axis of symmetry. So you take a negative b, and b is always the number that's attached to the x. So since the 8 is already negative, it's like a negative 8, and that turns it positive, over 2 times a, and a is just 1. So we have 8 divided by 2, which comes out as 4. So our axis of symmetry is x equals 4. The vertex you get by taking that value and plugging it into the original equation. Okay, so we are going to take f of 4. So we always take whatever this x coordinate is and sub it into the equation. So we have 4 squared minus 8 times 4 plus 17. And all that work, I don't mind if you guys just plug that right into a calculator. Okay, so your vertex is always going to have the same exact x coordinate that we just wrote down for the axis of symmetry. Remember, when you make your table of values, that value should always be the center, and then you're going to go up and down from there. So we go down, 3, 2, 1, and we go up 5, 6, 7. So like I said, I do not mind at all if these values just get subbed into a calculator. Desmos works, a graphing calculator works. So we're going to start with the 1 right here. So we will have 1 squared and then minus 8 times 1 plus 17. So you're going to do that for each one of these values. So we have 10 first. Do the same thing with the 2. And then 4, so this value is our vertex. This is the one that I wrote down the work for. And then we've got 3 more values. We have the 5, the 6, and the 7. So take 5 and square that, minus 8 times 5 plus 17. And then you guys will notice that these, it's called the axis of symmetry for a reason. The value that I plug in to the right of the vertex should be the exact same value that I get to the left of the vertex. And when you're just starting these off, it's always a good idea to double check, but the value that I get for the 6 should be the exact same value that I got for the 2, which it is, and then the value for the 7 should be exactly the same as the value that I got for the 1. Which it is. So those values are going to get written down on the table. So this is what I had here. 2, 1. And then the values repeat back because you've got this symmetry. Of course, that's what the axis of symmetry means. These values are going to get plotted. The vertex that I have written down here was 4, 1. And then we're going to plot all 7 of these points here. So 110 be up 1, 2, 3, 4, 5, 6, 7, 8. And then we can go 9, 10 would be right around there. You're just kind of estimating anytime it goes off the graph. 2, 5, be right there. 3, 2, 4, 1, and then you repeat the symmetry back on the other side. So it goes up there, and there, and there. So you've got this perfectly symmetrical graph. You're going to connect the dots, make this sort of U-shaped parabola out of it. It should look like that. So let's look at what we've got so far. We determined the min or max, found the axis of symmetry, found the vertex, and then graphed using a table of values. Last thing that we need to find is the domain and range. The domain, every single one of these graphs that you do, the quadratic graphs, the domain will always be all reals. Okay, so that's just a really easy thing to remember, is that it is always, every single time, going to be all reals. All right, and then the range is going to base on what the vertex value is. So 1 is the minimum y value. So if something's the minimum, it means it hits that value and then goes up from there. So our range, we would list out all the y values, and we say the y values are greater than or equal to 1. So 1 was the minimum value, which means the values only go up from there. All right, we are going to do one of the inequalities as well. So let's do number 7. So this one, you still have to do the work to find the vertex. I'm requiring you to write down less stuff for the inequalities, but we still need to figure out what the value of the vertex is. Remember, negative b over 2a, so negative 6, that's the b, and then divided by 2 times a, so that's 2 times 1. So this is a negative 3. We use that negative 3 to center where our graph is going to go. We go down, and then we go up. Okay, so really remember with the symmetry, you only need to technically plug in the first 4 values, and then they start to repeat themselves after you hit the axis of symmetry. So when I plug in the negative 6, be super careful with that first value. Make sure that you're plugging it in parentheses before you square it, because otherwise you're going to end up getting the wrong value. So whenever you're subbing your table value in, it should go in parentheses. Okay, so we've got that. Do the same thing with the negative 5. And then the negative 4. And then the last one that you need to do is the negative 3. Okay, so we've got those values, and then remember the symmetry is just going to make it repeat itself. So 5, 0, negative 3, negative 4. And then the symmetry makes those values repeat themselves back. Okay, so we start with those values, plot them. 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. Negative 5 is at 0. Negative 4 is down here at negative 3. Negative 3 is down at negative 4. And then those values show their symmetry by repeating back like that. Okay, so you graph, this part is so far the exact same as what you had with the actual equations. With the inequalities, you want to do 2 things. First, you look to see if it has the or equal to. If it has the or equal to, it's a solid line. So that's what we're doing here. If it doesn't, then it's dashed. And then this one is a less than. If it's less than, you shade under. If it's greater than, you shade above. So we're going to shade underneath. And once that shading is done, then that will be our final graph.